In reviewing Chapter 6, we'll start with the first section, factoring greatest common factor. Just a reminder that the greatest common factor is the largest polynomial that divides evenly into all monomial terms. With numbers, you just kind of look at the numbers and figure out what is it that goes into all of them. With variables, the easy way to figure it out is it's just the lowest power of each variable. So if I'm going to determine the GCF for the following groups of terms, letter A, I have two different variables, P's and Q's, and I'm looking for the lowest power of each. So I have P and Q, P to the third Q, and then just Q squared. So my lowest power for the variable P is that there is none on this third term. And then my lowest power for the variable Q is Q to the first, and I can just pick whichever one. So my GCF here is just Q. That's the only expression that they all have in common. On part B, looking at my numbers, 16, 8, and 20, I need the largest number that goes into all three of them, which is going to be 4. And then I look through my x's and I find the lowest power is x to the 4th. And I look through my y's and the lowest power is y squared. And so that's the GCF for part B. What we're going to use GCFs for is to factor a monomial from a polynomial. To do so, the first thing we need to do is determine what the GCF is, just as we did in the first example. And then we're going to divide each term by the GCF. We're going to write our answer as the GCF multiplied by the result of our division. And then you can always check by multiplying. So if I want to factor in letter A, the GCF for 8 and 24 is 8. And then the lower power variable is P to the third. So what I'm going to do is I'm going to take 8P to the 4th divided by 8P to the third, which is just P. And then I'm going to take 24P to the third divided by 8P to the third and get 3. Now, most of the times you'll do this work here just in your head. You don't have to write it out. So for part B, the GCF, 4, 10, and 18, all can divide by 2. Lowest power A is to the first. Lowest power B is squared. So I'm going to divide each term. So I get 2A minus 5B plus 9A squared B squared. And that's factoring its GCF. Letter C has something special. When you start off with a negative, you want to make sure you factor a negative for your GCF. So 5 and 10 both divide by 5, but because it leads off with negative, I'm going to use negative 5. And the lower power variable is y. And when I divide, I get positive y squared minus 2. The other part of section 6.1 is factoring by grouping. Factoring by grouping you use with 4-term polynomials. So the first step's the same for any factoring that you're going to do, and that's going to be to factor any overall GCF that you may find. You don't always have one, but you should always check. Step 2, factoring by grouping. You're going to split the problem in half. So instead of one 4-term problem, you have 2 2-term problems. From each half, you're going to factor the GCF. Then, you're going to have this set of matching parentheses, which is called a binomial GCF. You're going to factor the binomial GCF, which is the matching parentheses, out of step 3. So in our first problem, all those numbers divide by 5. My overall GCF is 5. When I divide that out, my remaining 4-term polynomial is going to be factored by grouping. So I'm going to ignore the 5 for a minute. I'm going to take just what I have in the parentheses, split it in half. From the first half, the GCF is x squared. When I divide that out, I get x minus 2. The second half, GCF is a positive 3, so it is important to put your sign there. So positive 3, divide that out, you get x minus 2. So this is what I was talking about with the matching parentheses. So I factor out the x minus 2. When I factor out the x minus 2, what's left is x squared plus 3. That would be those terms I factored out earlier. And then don't forget the 5 in front. Part B has no overall GCF, so I split the problem in half. First half, GCF is t. Divide it and get r plus 3. Second half leads off with a negative, so my GCF is negative 5. Divide by negative 5 and get r plus 3. R plus 3 and r plus 3 match. So I factor that out, leaving t minus 5. On part C, we split it in half. First half, GCF is x. Second half doesn't have any GCF, but I have to use something. So if there's no other GCF, we just use a positive 1. Which leaves this unchanged. But that's okay because 2x minus y matches with 2x minus y. And then we have x plus 1. And that's our factoring by grouping.